I'm Shoichi Inaba, and I'm here today to introduce the ambient temperature slide or the ATS method. So let me begin. First of all, although I plan to give a little demonstration of our software, I gave up on it because I couldn't prepare enough for this online presentation, and I'm so sorry for that. At the outset, I would like to introduce the organization to which I belong. Toyo Institute of Food Technology, or TIFT, was founded about 60 years ago, and we have been involved in handling of packaged food since then. Mr. Takasaki, the founder of our corporation, is the same who founded the Toyo Second Company, which is the biggest general packaging manufacturing company in Japan. We are from the western part of Japan near Osaka, and as you can see, we have a statue of Nicholas Appel there. Our research focus is primarily divided into three parts, namely food material, food processing, and food science. This is what I will cover today in my presentation. It is composed of 5 broad parts. The purpose of this presentation about the ATS method, introduction to the ATS program, thermal processing tests, and the conclusion. The purpose of the presentation is composed of 2 parts. Firstly, I will give an introduction on the theory behind the ATS method. Secondly, I will explain how the ATS method works in comparison to the board formula method. I'd like to tell you how we can set better thermal processing conditions. Do you ever have trouble testing thermal processing? If you change the initial product of the temperature, do you know how it affects the F0 value, C0 value, and total time? It can be said about these parameters, the parameters such as process temperature, process time, cooling water temperature, come up time, and come down time. By the way, for those of you who don't know what F0 and C0 values are, I will explain them in the following slide. F0 value is related to the sterilization effect, and the C0 value is related to the heat degradation degree of packaged food. Now, let me show you the new conventional way of how we develop our new product or improve our thermal process. As you can see, we run several tests, which makes the process very time-consuming. The process becomes material and energy-consuming, and our staff gets very tired because they run a very large number of tests until they get an acceptable level of quality, making it time-consuming as well. Now, let me show you the new way of the product development and improving process by using the ATS method to circumvent those issues related to the conventional method. ATS method is a numerical analysis and calculation method for thermal processing. In this case, we run a trial run of thermal processing once with the specific packaged food to get the parameters of ATS. Next, we estimate the core temperature after setting a virtual ambient temperature pattern. In this way, we can set the virtual pattern and estimate it it several times until we are satisfied on our PC, and finally, confirmation test is needed. The advantage of using the numerical calculation method are short time and time cost effectiveness. Then I would like to explain how the ATS is introduced. I'll begin with the explanation of how the board formula method is introduced. The packaged food is soaked in the hot water and the core temperature is being measured. The left side slide is balls and board formula method, and the right side is ATS. In this figure, the horizontal axis shows the time and the vertical axis shows the temperature. The board formula method, the ambient temperature is assumed to be constant and the core temperature changes like this. This expresses that the core temperature changes in proportion to the temperature difference between ambient and the core. And this equation, which uses the coefficient slope index f and the lag factor j, was introduced. In ATS method, the ATS method was proposed by Mr. Mukai in 2006. In ATS, the ambient temperature is assumed to be curved. And this model shows the packaged food during the thermal processing. And I'll show you the next assumption, that ambient heat takes time delta to reach the core of the product after changing the ambient temperature, changing the ambient temperature. So the core temperature changes with the shifted ambient temperature by the period of time delta. The core temperature changes in proportion to the ambient temperature difference between the shifted ambient and the core. After all, the core temperature is determined using the coefficient tau with this equation. In this slide, I'd like to say that the ATS was introduced by almost the same way of ball, and ATS is another calculation way of adapt to various kinds of ambient temperature patterns. What come up time and come down time are rather long and not rectangle shape, for like cup foods. Let me compare both formula method and ATS in this table. These methods have 4 parameters each. Although just the F0 value and the process time is calculated by both formula methods, the profile of the core temperature can be calculated by ATS, so we can get 3 parameters, the F0 value, C0 value, and total time by ATS. Ball is mainly analog calculation, but ATS is calculated by digitally. When we use ball method, we have to study the mathematics hard and use it carefully in proportion to ambient temperature patterns and so on. Using ATS just requires basic Microsoft skills without math knowledge. Finally, I don't know any software which can handle ball easily. If you want to try ATS, You can instantly download the free open source software from our website. The reason we provide this software free is that we work for the public in Japan. I'd like to show you the program which I significantly improved based on the work of Mr. Mukai. This program runs on Microsoft Excel, and this sheet that you can see on the slide for acquiring the optimum parameters. The thermal processing test data is already pasted in this area, contains the time, ambient temperature, and core temperature. The time interval of this is 3 seconds, and the data is composed of 1,370 lines. Although you click these two buttons, the calculation start and the result are displayed in these 4 locations in only 30 seconds. The calculation time depends on the data and the PC. This screenshot shows how to make virtual ambient temperature pattern using the table. And this figure is the virtual ambient temperature pattern I made. After you click these two buttons, the calculation of core temperature based on this virtual data begins. In addition, the ambient temperature data you get by the other test can be used. This screenshot shows the estimated result of the calculation, which I have showed in the previous slide. In the result, if the results are not satisfactory on the first trial, you should fine-tune the virtual data and perform calculations repeatedly until you get an acceptable result. This table is expanded table on this upper side. These are the final piece F0, C0 total time, and C0 value of core, C0 value of surface. The stop F0 is the coined word, which indicates the timing when heating phase to move to cooling phase. In the following slide, I will explain how I did the thermal processing test. The objective of this test is comparing both formula methods and ATS, and to know which is more precise between the two. This slide explains the experimental method. I ran 3 cases of thermal processing test using 3 types of packaging food. They were canned, pouched, and plastic cupped 6% liquid starch. In each case, the process temperature was set to 117 degrees Celsius, 120 degrees, and 123 degrees. After test finished, the results of the test are estimated each other using the parameters. This explains the 2 types of the numerical calculation method, ATS and BO. For example, case 1, the product temperature of 120 degrees Celsius was calculated using the temperature of ambient temperature of 120 degrees and the parameters at 117 degrees. So, and if F0 value and C0 value and total time are calculated. In case 2, the test, the ambient temperature at 123 degrees were used. The results of the test were evaluated by the error ratio ER, which is expressed by this equation. C is calculated, M is measured. So this equation compares the C and M. The smaller the error ratio is, the more precise the calculation is. Let me show you the aging error ratios from each process temperature and packaged food. This shows the result of the error ratios of the F0 values. Left side is bowl and right ATS. These were canned, pouched, and cupped, can, pouch, cup. The lower number of the number of temperatures of the parameters get, and upper number temperature of ambient. So 3 types of packages, 3 types of temperatures, and 2 types of the combination makes 18 results. The vertical axis is the error ratios of the F0 value. The average error ratio of ATS was 0.3%, almost 0, and the average error ratio of the bowl was negative 26%, which was spread 3 times wider than ATS. I will show you the table which include other error ratios of the parameters such as C0 and total time. Left is bold, right is ATS. From upper side, F0, C0, total time. As seen in the table, the C0 value and total time cannot be calculated by board. And these two average of the ATS were most likely 0 and were spread narrowly. From above results, it is clear that the ATS was much better than board method.